The creators of CRISPR gene editing thought it was impossible to make it better. But a new AI system called PROTEUS isn't just enhancing CRISPR, it's creating proteins that have never existed before and turning mRNA medicines into supercharged treatments that could change medicine forever. Welcome back to AI Handbook channel, where I expose the revolutionary changes happening in artificial intelligence every single day. By the end of this video, you will understand why this Australian discovery might be the most dangerous breakthrough in human history, and why the fact that they made it completely free could either save humanity or unleash consequences we're not prepared for. But first, let me show you exactly how close we came to losing the war against superbugs forever, and how one AI system just changed the rules of life itself. Right now, as you're watching this video, antibiotic-resistant superbugs are killing 35,000 Americans every year. These bacteria have learned to resist every weapon we've thrown at them. Traditional drug discovery takes 10 to 15 years and costs over $1 billion. By the time we develop new antibiotics, the bacteria have already evolved to resist them. But what if I told you that scientists in Australia just figured out how to beat evolution at its own game? The answer lies in the technology that sounds like science fiction. Meet PROTEUS, which stands for Protein Evolution Using Selection. This isn't just another AI tool. This is a system that can literally control evolution itself. Here's what makes it revolutionary. While natural evolution takes millions of years, PROTEUS can run the same process in just weeks. The system uses something called directed evolution, but here's where the story gets intriguing. Directed evolution worked perfectly in bacterial cells, earning its creators the 2018 Nobel Prize in Chemistry. But when scientists tried to make it work in mammalian cells, the cells that are actually relevant to human medicine, it failed every single time. Until now. What the Australian team discovered would change everything. The Australian team at the University of Sydney had a brilliant insight. The problem wasn't the concept, it was the execution. Mammalian cells couldn't handle the stress of multiple evolution cycles. They would either die or cheat the system by finding shortcuts that didn't actually solve the intended problem. So the scientists created something unprecedented, chimeric virus-like particles. They took the outer shell of one virus and combined it with the genes of another, creating the perfect evolutionary laboratory that could withstand the pressure while maintaining integrity. But even the researchers weren't prepared for what PROTEUS could actually accomplish. Think of PROTEUS like giving a prompt to ChatGPT, but instead of generating text, it generates new life forms. You can ask it, how do I efficiently turn off a human disease gene? And PROTEUS will explore millions of possible molecular solutions until it finds the perfect answer. The researchers have already used PROTEUS to create enhanced proteins that can be controlled more precisely by drugs, nanobodies that can detect DNA damage that drives cancer, and improved versions of CRISPR that are more effective than anything we've seen before. But what they created next would make even the most dangerous bacteria tremble in fear. Remember those antibiotic-resistant bacteria I mentioned at the beginning? PROTEUS just created their worst nightmare. The system designed artificial proteins that target a specific bacterial protein called CHU-A, essentially the bacteria's iron acquisition system, their lifeline for survival. These AI-designed proteins work like molecular assassins. They bind to the bacteria's iron transport system and starve them to death at nanomolar concentrations. That means incredibly tiny amounts can eliminate massive bacterial populations. When the researchers tested these proteins against E. coli, one of the most dangerous antibiotic-resistant bacteria, the results were nothing short of extraordinary: complete inhibition of bacterial growth without affecting human cells. Yet this breakthrough was just the beginning of something much bigger.
Here's what makes this even more remarkable. The Australian team made PROTEUS completely open source. They're giving this world-changing technology away for free to the global research community. Dr. Christopher Denis, the lead researcher, said, "We made this system open source for the research community, and we are excited to see what people use it for." This means laboratories around the world can now start creating impossible medicines, enhanced gene therapies, and solutions to problems we haven't even imagined yet. But the team's next target might be their most ambitious yet. Professor Greg Neely revealed their next target. Our goals will be to enhance gene editing technologies or to fine-tune mRNA medicines for more potent and specific effects. This could revolutionize COVID vaccines, cancer treatments, and genetic therapies. Imagine mRNA medicines that are 10 times more effective with zero side effects, targeting only diseased cells while leaving healthy tissue completely untouched. But Australia isn't alone in this race, and the competition is heating up faster than anyone expected. Australia isn't the only player in this game. This research puts Australia alongside the US and China as having indigenous AI-driven protein design capabilities. This isn't just about scientific prestige, it's about who controls the future of medicine. With antibiotic resistance representing a growing global health crisis, this AI-powered approach offers hope for developing new classes of antimicrobials that work through completely novel mechanisms. But before anyone could claim victory, the team needed to prove something that would silence all skeptics. The team didn't just create these proteins in theory, they proved they work exactly as designed. Using advanced cryo-EM structures, they showed that their AI-designed proteins matched their computational predictions with incredible accuracy. The structural analysis revealed something remarkable. The designed proteins occupied the exact binding sites they were programmed to target with root mean square deviations of only 0.6 angstroms. For context, that's precision at the atomic level. This level of accuracy opened up possibilities that sound more like science fiction than reality. We're just scratching the surface of what's possible. Scientists could now design proteins to break down plastic pollution in our oceans, help plants resist climate change and drought, create self-repairing metals, or develop personalized cancer treatments that adapt to each patient's unique genetics. Dr. Rice-Grinter explained, "These new methods in deep learning enable efficient design of proteins with specific characteristics and functions, lowering the cost and accelerating the development of novel protein binders and engineered enzymes." What we're witnessing marks a turning point that humanity has never experienced before. What we're witnessing isn't just a scientific breakthrough, it's the dawn of programmable biology. Proteus represents the moment when artificial intelligence became capable of creating new forms of life designed specifically to solve human problems. The impossible medicines aren't coming in 10 or 20 years. They're being created right now in laboratories around the world by scientists who just gained access to evolution's source code. The question isn't whether this technology will change medicine forever. It's whether we're ready for a world where the only limit to what we can cure is our imagination. What do you think about AI controlling evolution? Are we entering a golden age of medicine or opening a door we might not be able to close? Let me know in the comments below, and don't forget to subscribe for more breakthrough science content.